Welcome, ladies and gentlemen. So what I like to do is just kind of go over what is it, everything you need to know to be able to, to be able to write the equation of a perpendicular line to another line that goes through a given point. So the kind of things, the basics that you're going to need to know to do that is first understanding what perpendicular lines are. Unlike parallel lines that never intersect, perpendicular lines are going to intersect. And when they intersect, they're going to create a 90-degree angle. And sometimes we call those orthogonal lines. So if I had, like my x and y axis here, an example of parallel lines is here's one line, and let's say here's the other. Again, they create a 90-degree angle. All right. What's also important about that is not only since parallel lines have the same slope, perpendicular lines have what we call opposite reciprocal slopes, which I kind of will touch on here a little bit. So if the slope of, let's say, this slope in this line is, let's say, -3/2, then the slope of this line is going to be +2/3. So remember, they're reciprocals of each other, and if one is negative, then the other one is going to be positive, and vice versa. The next thing you're going to need to know is slope-intercept form and point-slope form. In this course, I'm going to use both of those equations to help us identify the perpendicular line to another line going through a point. So make sure that you understand that mx plus b is what we call slope-intercept form, where m represents the slope and b represents the y-intercept. And point-slope form is y2 minus y1 is equal to m times x2 minus x1, where x's and the y's represent points that lie on the line. The next thing is really just kind of have a basic understanding of what is slope and what is y-intercept. As I mentioned, the slopes of these two lines are opposite reciprocals of each other. But what exactly does slope represent? Slope basically represents the change in vertical and horizontal distance of 2 points that are on a line. And notice that here my change, which vertical is rise and run. So you can see that the change in these two is going to be opposite reciprocals of the change here, where now here is the run and here is the rise. So you can see they've kind of been flip-flopped, and that's why we talk about opposite reciprocals when we're dealing with slope. The last thing is to know how to evaluate a point on a graph. We're going to be given points that are going to be going through a line. So we're going to want to make sure that we know what does that really represent, because there's points that lie on a line, and there's also points that do not lie on a line. So how do we know, or what do we do when we have a point that lies on the line? So for instance, let's just look at an equation. Y equals 1/2 x plus 1. And I'll actually give an equation here that works. What about if I had 4, 3? And what we want to do is determine, well, if that point goes through a line, how do we know that it goes through that line or through this equation? And let's just pretend this is an equation on a graph. Well, to do that, what we simply do is plug in the points for x and y. And we have 3 equals 1/2 times 4 plus 1. Well, 1/2 times 4 is equal to 2 plus 1. 3 equals 3. Now, if this wasn't true, then that point would not lie on the line. It'd be like a point that's off there. But since this point lies on the line, since this point makes this equation true, that means we know that it's going to lie on the line. So just a very important point as we're working through this course. But that is about everything that you're going to need to know to be able to write the equation of a perpendicular line through a point. Thanks.